drop a like and do share. Leave your comments and do not forget to subscribe for more videos.
Hi everyone, welcome back to the course on Introduction to Material Science and Engineering offered by Edupedia World. Last lecture we discussed about some of the physical properties of the different microstructures of steel, and we concluded discussing about martensite and said that martensite is too brittle to be used in as-quenched condition, and we suggested heat treatment known as tempering heat treatment to recover some of its ductility. Let's discuss about the heat treatment today. The heat treatment tempering results in something known as tempered martensite. So basically, martensite undergoing tempering gives us tempered martensite. Now what exactly is happening? As I said, as-quenched martensite is very brittle. Therefore, tempering heat treatment is used, and what does it do? It does two things. It improves the overall toughness of the material and it relieves internal strain. This increase in overall toughness and relieving in internal strain leads to improve of ductility. Okay. Now what exactly is the heat treatment that we are carrying out? What exactly is tempering? Tempering is generally done at somewhere in the range of 250 degrees Celsius to 650 degrees Celsius. This is the range of temperature where we carry out tempering. Normally we carry out it between 250 degrees Celsius to around 375 degrees Celsius. Why so? As I will discuss, beyond this temperature there is something known as tempering embrittlement, which leads to further brittleness of the material due to the tempering itself. Okay. Now tempered martensite has a different microstructure. The martensite as-quenched condition was basically needle-like shaped supersaturated carbon BCT structure of iron. Tempered martensite on the other hand, due to the exposure to high temperature for a scheduled time, has given it time for diffusion to take place within the material. As a result of that, what has happened, we get ferrite matrix, and in that ferrite matrix very fine dispersed cementite particles exist. These cementite particles are very fine particles. There is another kind of microstructure known as spheroidized iron. Spheroidized iron also have spherical cementite particles in ferrite matrix, but in spheroidized iron, which is quite a soft microstructure, the cementite particles are relatively large. Tempered martensite on the other hand has extremely fine cementite particles. These extremely fine cementite particles dispersed throughout acts as a very good site for blocking of dislocations, thereby strengthening mechanism comes into picture, and the strength of tempered martensite is very high. At the same time, since we have ferrite matrix which is quite soft, rather quite ductile, gives the toughness, required toughness and ductility to the tempered martensite. Okay. Now as I said, with increase in time and temperature, what happens? More amount of diffusion can take place with increase in time and temperature. Thereby the strength decreases, right? Because martensite is very strong. Martensite is starting to lose supersaturation, thereby its strength starts to decrease, but the ductility improves. So depending on our end requirement, we need to decide on the combination of time and temperature we will temper the martensite for. Okay. Now as I said in the previous slide, tempering between 375 and 575 degrees Celsius leads to a phenomena known as temper embrittlement. And temper embrittlement is embrittling of the material due to the tempering process itself. Will not go into the physics of why this happens. What you need to know for the time being is that it happens, and there are certain type of heat treatments which can be used to undo this effect. Now observed, this temper embrittlement is observed when steel has these alloying elements in quite a high percentage: magnesium, nickel or chromium. And in addition to those high percentage alloying elements, small amounts of antimony, phosphorus, tin, etc. might be present. These alloying elements kind of lets temper embrittlement happen much more effectively in the material. So if your alloy has these alloying elements, then it is better to avoid this temperature range for tempering. Better to remain at temperatures around 350 degrees Celsius for maybe longer time. Okay, so now we understand that the martensite which we obtained from as-quenched condition can be heat treated, resulting in a much more useful form known as tempered martensite. Next lecture we will see different kind of heat treatments that steel microstructure undergoes, and what are the requirements for those heat treatment and what are the purposes of those heat treatments. Till next class, have a great day. Goodbye.